Okay, this is a draft. I don't know if it's going to see the light of day, but if I go to the prior slide, this is something that's in the notes showing how 3 and 7 can be multiplied using Booth's algorithm. And the initialization, A becomes 0, Q becomes one operand, M is the other operand, Q minus 1 is going to be 0. And the way the algorithm works is it looks at these two bits, and based on these two bits performs one of three actions. So in this case with 1, 0, it's going to subtract M from A, which the other way of doing it, you can add negative M, and here's negative M, and then you do a shift. So here's the negative M, here's the negative M that's being added to A, so there is the sum of the A plus the negative M, and then the shift, all of the bits shift, well, for A and Q, every bit shifts one to the right, and then with the leftmost bit, the copy of this is what is brought into here. Anyway, the slides go through this example of 3 times 7. What I want to do here is do minus 3 times 7. So first of all, I want to come up with the binary representation for minus 3. So now this example here is using 4 bits. And so using 4 bits, the largest positive number we can have is actually 7. That we can't have 8 using 4 bits. But anyway, this is a 3. Okay, this is 3. That's 3. So to represent minus 3, we flip the bits. 1, 1, 0, 0. We add 1. Okay, that's the flipping of the bits. And then we add 1, and we have 1, 1, 0, 1. And so this here is minus 3. So this is minus 3. And so Q, we'll use here as the starting point for Q, the 1, 1, 0, 1, which is the minus 3. A gets initialized to 0, so these are all going to be zeros. Q minus 1 is going to be initialized to 0, and M is going to be the other operand. Well, the other operand that we're going to have is going to be 7, and so 7 is 0, 1, 1, 1. So 0, 1, 1, 1. Later, if we do get to the point where we're going to have to subtract M, instead of doing the subtraction of M, we can add the 2's complement, the negative of it. So if this is M, then let's flip the bits. 1, 0, 0, 0. That's the flip. And then we add 1. Whoops. I shouldn't have notation-wise. I shouldn't have put that. What I found, I'm going to publish this draft. So 1, 0, 0, 1 is negative M. Okay. So in Booth's algorithm, what we look at is for each step, oh, by the way, if we have 4 bits, there's going to be 4 steps after the initialization. If we have 6 bits, there's going to be 6 steps. So depending on how many bits we have, if we did have 32 bits, we would do 32 steps in terms of the process. And what each step does is it looks at these 2 bits, what's known as Q0 and Q minus 1. And depending on what these 2 bits are, we do one of 3 things. Well, 1, 0, that's this one right here that we're going to do. And the first thing it says, we're going to subtract M from A. Well, here's A, but instead of subtracting M, we're going to add negative M. So we'll add to this 1, 0, 0, 1. And the sum of this, well, I technically really should, just to be consistent, start from the right. So 0 and 1 is 0, 0 and 0 is 0, 0 and 0 is 0, 0 and 1 is 1. What I'm going to do is, just because the next thing we're going to do is a shift, I just want to, sorry, I was going to indicate here that this is minus m. Since the next thing we want to do is a shift, I just want to copy these bits down before the shift, so that when we do the shift, it's just easier dealing with the shift from here. So the 1 shifts here, 0 shifts here, this 1 shifts here, this 1 shifts here, this 1 shifts here, this 0 shifts here, this 0 shifts here, this 1 shifts here. Well, now we have this leftover bit on the far left, and what we do is we're going to make a copy of the leftmost bit, which is 1, and so we'll have 1 here. And so this now finishes the first step. And so every step is going to go through the same process, that we are going to look at these bits here, 0, 1, figure out, okay, based on that, we will, in this case, we are going to add m to a. Well, here is our a. M is the 0, 1, 1, 1. So 0, 1, 1, 1. And so this is the m that is being added. So 0 and 1 is 1. 0 and 1 is 1. 1 and 1 is 0, carry the 1. 1 and 1 and 0 is 0, but there is no carry. Again, I'm just going to copy the row I'm realizing I'm looking at my handwriting and realizing I think I screwed up. Thank God this is a test. This was the copy, the 1101, and then the 11 over here, the 01 over here. That is supposed to be a 1. I mean, that is a 1. That was a 1. That 1 came over here. Okay, so let me just copy these down. So 1, 1, 0, 1, and now we'll do the shift. So the 0 comes here. 1, 1, 1. This 1 shifts over here. It's going to be a little bit clearer on this. This 1 shifts here. The 0 shifts here. The 0 shifts here. And then we want to do, again, a copy. So I want to do a copy of this right here into this bit here. And so then this is a 0. This finishes step 2. So again, we look at, in this case, the 1 and the 0. Oh, I'm sorry, what I haven't been doing was copying down the m in each case. The m is unchanged in the algorithm. 1, 0 is this piece. So we want to subtract m. So the negative m is the 1, 0, 0, 1. And just a reminder, this is the negative m that is being added. Okay, 1 and 1 is 0, carry the 1. 1, 0, and 0 is 1. 0 and 0 is 0. 0 and 1 is 1. I'm just going to, before the shift, just copy these bits down here, just so that the shift will be a little bit easier. So the 1 is here. This 1 is here. This 1 is here. This 1 is here. This 0 is here. This 1 is here. This 0 is here. This 1 is here. And so I'll make a copy of this one here to here. That finishes that step. And now we'll look here. 1, 1. Well, 1, 1 is this, which is going to just do the shift. And so just to make the shift easier, let me just copy these things down. Yep, I did it again. That is a 1. And now when I do the shifts, this one shifts here. This one shifts here. This one shifts here. This 0 shifts here. This 1 shifts here. This 0 shifts here. This 1 shifts here. This 1 shifts here. And then, of course, we'll make a copy again. And we'll make a copy of this 1. And that 1 comes here. So the result of what we have now in 8 bits, 1, 1, 1, 0, 1, 0, 1, 1. Well, because of this 1 here, it's a negative number. So to figure out what this is, let me flip the bits. 0, 0, 0, 1, 0, 1, 0, 0. And if I add 1 to this, we end up with 0, 0, 0, 1, 0, 1, 0, 1. That's because of the adding of 1. And so this is the result, or this would be the positive version of the result of the number that we have. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. 2 to the 4 is 16. 16 plus 4 is 20. 20 plus 1 is 21. So that means that this result right here, that is a negative 21. Remember, we began with, this was minus 3. This was our 7. Minus 3 times 7 is minus 21. That's the result of the binary multiplication. What a disaster.